Hi, in this video we are going to see about a Python IEEE project which is entitled as Optimized Electricity Bill Prediction Using Machine Learning Techniques, which is an enhancement of IEEE base paper title, a temporal spatial graph network with a learnable adjacency matrix for appliance level electricity consumption prediction, which is an IEEE 2025 transaction paper. So before seeing the execution of the project, let me brief about this project. So today, all over the world, we know that electricity has become one of the important and major component for every human being, because everything that we use requires electricity. Even the vehicles that used fuel is now required are changing to EV, that is electrical vehicle, so that we require electricity for it. And for cooking, we have used the gas stoves, and now it is replaced to electrical gas stoves like induction stoves kinds of thing. So now whatever the component or whatever the thing that a human use requires electricity for it, so the demand for electricity is growing every day, day by day. So now we wanted to monitor it so that the electricity can be utilized in a proper way. So in this base paper, the authors have introduced the artificial intelligence for the appliance level electricity consumption prediction, so which is known shortly as ALEC. So in this base paper, the authors have introduced a concept called a graph-based temporal spatial network that employs a learnable adjacency matrix for appliance level load prediction. So in this base paper, the authors have utilized the ALEC prediction method by constructing a graph that includes all household appliances and learn the adjacency matrix that optimizes the relationship between the appliances. So here you can see the details of the base paper, but kindly note that we are not going to use the same as mentioned in the base paper. So now let us see about our proposed system and what we have made the novelty in it. So here you can see our proposed title, Optimized Electricity Bill Prediction Using Machine Learning Techniques, and this is the IEEE base paper title and this is the IEEE base paper abstract. So as mentioned in the base paper concept, they have used the appliance level electricity consumption prediction, but here in our proposed system to forecast the electricity bill. So in every houses or every organization will be receiving the electricity bills. So only after getting the electricity bill, the user can able to know what is the electricity bill amount. So if the user knows the electricity bill earlier, then they can able to reduce the price in case if the electricity bill amount is higher, so that they can able to save the money and also save the electricity. So in this proposed system, we are going to introduce the optimized electricity bill prediction using machine learning techniques. So for this, we have used two different machine learning models. So now let us see about the details of the machine learning models, and here you can see the first model is stacking regressor and second one is random forest regressor. And here kindly note that this is a regression problem. So in the machine learning for other projects we could have seen about the classification problem, but this is a regression problem. So here the first model, that is stacking regressor, we have achieved the training set mean absolute error as 0.82 and test set mean absolute error with 1.50. And second model, random forest regressor, we have achieved the training set mean absolute error with 0.55 and test set mean absolute error with 1.32. So coming to the proposed abstract, you can see we have introduced the concept of optimized electricity bill prediction using machine learning technique, and we have developed this project using Python as the backend, and for the front end we have used HTML, CSS and JavaScript and integrated with the Flask web framework. So here in the dataset part, coming to the dataset part, we have utilized a dataset which contains 45,000 345 dataset records. So now let me show you the dataset, then we come back again to the abstract part. So in the model part, we have provided this electricity bill dataset. So this dataset contains the features of fan, refrigerator, air condition, television, monitor, motor pump, month, city, company, monthly hours, tariff rate, and the electricity bill amount. So here you can just scroll down and see the complete data set with the data set record of 45,345 data set records. So here you can see the values of the fan, refrigerator kinds of things. So you can know that this is the daily usage hours. So per day, how much time, how much hours the fan was utilized. This was the value that is mentioned here. Like that, similarly the refrigerator, the air condition, television, monitor, motor pump, which month it is October month, and which city and which company is providing that electricity, which comes under which company, and monthly hours, the tariff rate, and then the electricity bill. So this data set is going to train with our model, and it is going to predict the electricity bill amount. So now coming back to the abstract part. So here we have mentioned about the details of the data set. So the data set includes the comprehensive features such as number of electrical appliances like fan, refrigerator, air condition, television, monitor, motor pump, time-based parameters, month, and the geographical indicators, and the consumption metrics like monthly hours and tariff, with the target output being electricity bill. So after the data set, we are going to pre-process the data set. So for the pre-processing, we have utilized label encoding of categorical features, removal of redundant columns, and structured feature target split for training. So after that, the two regression models are employed in it. So after that, we have achieved the random forest regressor with the training mean absolute error MAE of 0.55 and test MAE with 1.32. Then the stacking regressor combining multiple learners, which achieved a training MAE of 0.82 and test MAE with 1.50. So both the model demonstrated the effective performance in predicting the electricity bill, with random forest showing the slightly superior generalization capability. So these details have been mentioned in the abstract part. So coming to the existing system, so we are going to take the base paper as the existing one. So in the base paper, as mentioned, they have proposed a notable approach, which is temporal spatial graph network with learnable adjacency matrix for the appliance level electricity protection. So here in the framework, the authors have introduced the graph based deep learning method to predict the electricity usage of the individual appliances. And in the system, the existing system, household appliances are modeled in such a way as a node in a graph, and the edges represent the inner relationship between the appliances usages. So those details are being mentioned in the existing system part. So coming to the disadvantages of the existing system. So the main disadvantages of the existing system are complexity of architecture. Second one, high dependency on time series data. Next, requirement of appliance level monitoring. Then scalability challenges. Next, training overhead and long convergence time. Next, difficult to interrupt and deploy, and finally limited use in building appliances. So these are the main disadvantages of the existing system. Now let us see about the proposed system. So as mentioned, the proposed system is focused on developing a predictive model to estimate the monthly electricity bills. So based on the aggregated household appliance usage data. So it is not like the traditional time series model that required in the existing system. It required per minute or per second data. But this system, that is our proposed system, utilizes the monthly level features. So based on that, it is going to predict the electricity bill. So this system, the proposed system, is developed using Python, HTML, CSS, JavaScript, and the Flask framework. Coming to the dataset part, as mentioned, we are using 45,345 dataset record which has the details about the fans, refrigerator, air condition, television, kinds of monthly hours data. So based on that, we are going to train the model. So in the model part, we are using two machine learning models, random forest regressor and the stacking regressor, and the performance evaluation metrics of it is been mentioned in it. So these are all the things that is mentioned in the proposed system part. Coming to the advantages of our proposed system, the main advantages are utilization of aggregated data, simplicity and computational efficiency, improved interpretability, user-friendly web interface, data visualization capabilities, high precision accuracy, scalable and modular design. So these are the main advantages of our proposed system. Now here you can see the difference between the existing and the proposed one in a tabular column. The left side shows the IEEE existing system and right side shows the proposed system. So in the existing system, complex graph-based temporal model for individual appliances consumption is being done. But here we are making a simple tabular data model predicting overall monthly electricity bill. So in the existing system, it uses the time series and GCN architecture, but here we are using the tree-based regressor like random forest and the stacking regressor. Next, in the existing system requires extensive per second or per minute appliance data, but here now proposed system use the monthly summary data. Then in the existing system, highly optimized for high frequency prediction, but here now proposed system is suited for practical billing prediction appliances for household or the companies. Now let us see about the system architecture. So the first thing is the data acquisition. So here we are using the electricity bill data set, which is then sent to the data pre-processing, which includes the label encoding, feature removal, feature target split process, and then it is given to the training process with the models of stacking regressor and the random forest regressor. Then the pictured results is shown. It will, after entering the details, we will be predicting the electricity bill amount and will be showing some static visualization graphs. So this is about the system architecture. And let us see about the system requirement. These are all the minimum hardware requirements, and this is the software requirement. So this project can be executed in Windows 10 or 11. Coding language is Python 3.12.0. Web framework is Flask. Front-end part contains HTML, CSS and JavaScript. And this is the reference, that is the IEEE base paper reference. So now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of the Python and the libraries installed in your system. So now go into the source code location. Inside that we have this electricity consumption prediction. So now in the address bar type cmd and click enter. So the command prompt window opens. So now here type python space app.py and click enter and kindly wait for a few minutes. So now after some time you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, paste it, click enter. So now you can see the project home screen or welcome screen with the project title Optimize Electricity Bill Prediction Using Machine Learning Techniques. So first click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and admin and then click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload part where you need to upload the data set. So just select the choose file option. Now go into the source code location. Inside the source code folder we'll be having this upload.csv file. So just select this upload.csv and click this upload button. So after uploading the data set, it will be navigated to the preview part where you can preview the data set that we have uploaded. So here you can see the data set details that whatever we have shown you earlier. So with the fan, refrigerator, air conditioner, television, monitor, motor pump kinds of things. So you can scroll down and see the complete details. So you can see that it is loaded with the complete data set part. So now come to the end of the page, you can see the click to train or test button. Just click this and kindly wait for a few seconds. So now you can see the training finish message and click OK. So now it will be navigated to the prediction part, which is the important part of the project. So where you need to enter the details of the fan, refrigerator, air conditioner, whatever the data set that we have shown. So here you can see the what is the feature, that is fan. So fan, we are going to enter the hours per day. So how many hours the fan was used for the day. So these details are already provided in the data set, the train and test data set. You can just check that and give it. So I'm going to give some few sample cases. I'm going to give fan with 16 hours, then refrigerator with 23, AC air conditioner with 2, television with 6, monitor with 1, motor pump with 0, and here you can enter the month of the data set. So here I'm just entering the month as 10, and the city is Hyderabad. So you can enter see the details of the cities whichever is available in the data set. You can just select it. So I'm selecting the Hyderabad for this case, and monthly hours aggregated value is 384, and tariff rate is 8.4, and here you can see the final selection, that is you need to select the required model. So as we have used two models, stacking regressor and random forest regressor, it will be listed here. So you can select whichever model you wanted. I will be showing this both the cases. So first let me select the stacking regressor and then click the predict consumption button. So now it will be showing you the result page, so where you can see the prediction result with the input values whichever you have entered. So I have entered the input value of fan with 16, refrigerator with 23, air conditioner with 2, television with 6, monitor with 1, motor pump with 0, month 10 Hyderabad, on monthly hours, tariff rate, and model selected was stacking regressor, and here you can see the predicted result is 3225. So you can just open the data set and you can just verify it. So here you can see this is the first value that I have entered with the details. So I'll just show you that. Before that, you can see the prediction result, and you can see a button called download PDF. So here we have given this additional option so that the user can able to download this electricity prediction result as a PDF format. We can export that result so that it will be useful for the future reference. So here you can see, now I'll show you with the data set. So we have used the same details of the data set, and you can see what is the predicted result, which is nearly to the same. Now below the download PDF, you can see a graph, a dynamic graph which shows according to the data that we have entered. So here user can able to visually see that which appliances consume the more energy. So here you can see the refrigerator has consumed the more energy with 47.9%. Then comes the fan with 33.3%, and monitor with 2.1, television with 12.5, and air conditioner with 4.2. So here this will be varying, this graph will be varying according to the input values that user is providing. I'll show you with the other case now. So now if you wanted to check with the other case, just click this prediction menu again, so that it will be navigated to this part. So this time I'll just enter the fan with 11, refrigerator with 22, air conditioner with 3, television with 19, monitor with 1, motor with 0, month as November 11, monthly usage as 565, and city as Ahmedabad, and tariff rate is 7.9. So now this time I'll just select the random forest regressor and click the predict button. So now it will be navigated to the result page, so where you can see the details that I have entered and the model that I have selected, and you can see the result value is 4463. And now you can see similarly you can just download this result for future reference in the same way as we did for the earlier one. You can see the picture result, and now you can see the graph is now varied. So here you can see the highest usage is refrigerator with 39.3%. Then comes the television here, an air conditioner with 5.4, fan with 19.6. So in this way the graph will be varied according to the user values that we have entered. So now let me go to the prediction menu again to show you with the other case with the fan of 18, refrigerator with 22, air conditioner with 1, television with 3, monitor with 12, motor pump with 0, month of 7, and city is Noida, monthly hours is 414, tariff rate as 8.2, and let me select the static regressor itself and then click the predict button. So now you can see the model that I have selected is stacking regressor, and you can see the predicted result is 3,395 rupees for this consumer or user. And here you can see the visual representation of the consumption made for by the each appliances. And finally I'll just go to the prediction menu again to show you with the final case with the consumption of fan with 23, refrigerator with 23, air conditioner with 3, television with 60, monitor with 1, motor pump with 0, month with 12, and let me enter the city as Navi Mumbai, and monthly hours is 675, tariff rate with 9.3. Let me select as random forest regressor and let us predict the consumption now. So now you can see the predicted result is around 6,277 rupees for this user, and here you can see the visual representation of the consumption made by each appliances. So in this way you can check with the other cases that is provided in the graph, or you can give your own values and you can check it out. And now let us move to the chart part. So in the chart part we'll be seeing the various static visualization charts for this project. The first chart comes the model performance comparison, that is the mean absolute error with the stacking regressor and the random forest. So the stacking regressor with the training set mean absolute error with 0.82 and test set with 1.5, and for the random forest we have achieved 0.55 for the training set mean absolute error and test set mean absolute error with 1.32. And next chart contains the average appliances usage with the fan you can see with the overall the refrigerator, the data set that we have used contains refrigerator contains the more hour usage, then comes the fan, television, monitor and the air condition kinds of thing. Then next it shows the monthly average electricity bill amount for each month. You can see the data as lowest for the February month, and July as the highest one. Next graph comes the top 5 cities by average electricity bill. So the more bill amount is produced in Navi Mumbai, then comes the Mumbai, then comes the Pune, then comes the Nagpur, then comes the Chennai. So these are the top 5 cities by the average electricity bill that is provided in the data set part. And then comes the top 5 companies by average electricity bill. So these are all the top 5 companies that provides the average electricity bill. And next chart shows the feature correlation with the electricity bill. Then we are going to show the monthly average electricity bill chart, which shows the month versus electricity bill. Then this chart shows the electricity bill by city chart, so electricity bill by city. And then we show the plot for electricity bill chart. Then finally monthly electricity bill analysis chart. So in the graph part we are going to show the model performance comparison chart, then average appliances usage, monthly average electricity bill, then top 5 cities by average electricity bill, top 5 companies by average electricity bill, feature correlation with electricity bill, monthly average electricity bill chart, electricity bill by city chart, plot for electricity bill chart, monthly electricity bill analysis chart. So these are all the things that will be showing you in the chart part. And now let me log out. So before completion, let us see about the frequently asked questions for this project. So the first question is, what is the main objective of this project? So the primary objective is to predict the monthly electricity bills based on the household appliances usage. So using the machine learning models like random forest regressor and stacking regressor, we are going to achieve this main objective. Next question, which technologies are used in this project? So we have used Python for the backend processing, Flask as a web framework, HTML CSS for the front-end interface. Next question, what machine learning algorithms are implemented? So we are implemented two regression models. One is the random forest regressor, another one is stacking regressor. Next question, what type of dataset is used in the project? So dataset contains 45,345 dataset records, which contains the features like fan, refrigerator, air conditioner data. So here you can see the column with the description with the fan, which contain the description of it. So here the value that available in the data set shows the hours per day, refrigerator also hours per day, air conditioner hours per day, television hours per day, monitor hours per day, motor pump, whether a motor pump is used or not, month, so which shows the month, which month, January to December, and city, example Mumbai, Delhi, Chennai, like that, company, which power supply company, Tata Power or Grid Power kind of thing. Then we are going to show monthly hours, that is number of hours the household consumes electricity per month, and tariff rate per unit cost of electricity for that region or the company based on the company. Then it shows the electricity bill. For this is the detailed description of the data set that we have used. Next question, what pre-processing steps are applied to the data set? So we are going to apply three different pre-processing steps: label encoding, feature removal, feature target split. So these are all the three pre-processing steps that is applied to the data set. Next question, is the system web-based or standalone? So this system is fully a web-based one. Next question, can this system work without smart meters or time series data? Yes, the system is designed on monthly aggregated data and does not require any real-time or high-frequency appliance level usage data. Next question, what visualizations are included in the project? So finally we have shown the graph part, right? So those data visualization graphs are being mentioned here, which contains model performance comparison, which is mean absolute error chart, average appliances usage chart, monthly average electricity bill chart, top 5 cities by average electricity bill chart, top 5 companies by average electricity bill chart, feature correlation with electricity bill chart, monthly average electricity bill chart, electricity bill by city chart, plot for electricity bill chart, monthly electricity bill analysis chart. So these charts will be helping the user so that they can able to predict the usage behavior and the cost impact on it. Next question, who can benefit from using this system? So the main usage here is the households can able to benefit, utility companies and energy auditors and consultants. So household can estimate and manage the electricity cost. So utility companies, based on the demand prediction and customer engagement, they can able to work on it. And then energy auditors and consultants for building analysis and planning. So these are the people, they will be benefited by this system. Next question, can this system be expanded or customized? Yes, system can be as a modular architecture, and so that it can be enhanced to include more appliances also in the future part. Next question, how accurate are the prediction? The system, any system that we develop, we wanted to show the performance analysis. So here, as it is a regression problem, we are using the MEAE metrics for it, and we have achieved that for the random forest model with 1.32, for that making the predictions reliable for the general billing purposes. Next question, is any user data stored? So we are not going to store any user data, so that we have not used any database in the project. So no personal or confidential data is stored in our system. So final question, what are the difference between the existing system and the proposed system. So as mentioned earlier, the existing system, they use complex graph based temporal model, but here we are going to use simple tabular model for predicting based on the overall monthly electricity bill. Next, in the existing system, they have used the time series and GCN architecture, but here in the proposed system we have tree based regressor like random forest stacking regressor. The existing system there, it requires extensive per second or per minute appliance data, but here in our proposed system we use monthly summary data of the appliances. Finally, in the existing system they have used highly optimized for high frequency prediction, but in our proposed system it is suited for practical billing predictions appliances for household or the company. So these are the frequently asked questions, and this is all about the project optimized electricity bill prediction using machine learning techniques. And thank you for watching.